Hey, so I want to tell you about a real-world word problem that actually helps me in my quest to own as many automobiles as I can. I love cars, love cars. And there's this car I want to buy, and I want to buy this car. It costs $30,000. Now, all I've got right now, I guess I shouldn't say this, but I've got $27,000 right now in my back pocket, so don't mug me as I leave the studio. But I want to buy this car. It's so cool. Look at this car. Isn't that cool? Look at that thing. Isn't that neat? And it keeps going. Okay, it's not in the greatest shape, I admit, but listen to that engine. Oh, there you go, huh? Pretty cool, pretty cool. Even comes with a key. Comes with a key to start it up. Now the question is, whoops, and I just lost the key. Excuse me for a second. I just don't want to lose the key because I might need to drive that home tonight. Okay. All right, now, here's the deal. I've got $27,000 right now that I can invest in a bank account that pays 6% interest compounded quarterly. 6% interest compounded quarterly. I can deposit my $27,000. The question is, how long will I have to wait before I can actually buy this car, which costs $30,000? Okay, well, the thing to use here is this formula that gives us the future value, or the amount we have in our account after some time, given the present value, the interest rate, the number of compounding per year, plus the number of with the number of years that we invest. So just using that formula, what would we see? Well, in this case, the amount I want at the end of the day, or in this case, the end of the term, whenever that is going to be $30,000. That's the future value. So that equals the present value, the amount I deposit in the bank account right now. So that's $27,000. Times 1 plus the interest rate. Now this is at 6%, so that's 0.06, divided by the number of compounding per year. Now it's quarterly, so that means 4 per year. And I raise that to the power, the number of compounding per year times the number of years. Now the question is, how many years will I have to wait? So I don't know t, but I do know m is 4. So this is 4t. And why am I talking about this kind of question now in this particular area of our discussions? Well, because I want to solve for t, and notice t is in the exponent. So what do? Well, I'll probably have to take logs at some point. So the very first thing I would do is actually divide both sides by the $27,000. Because if I bring that over here, then I'll just have something with that exponent. Notice if I bring that over, I can get rid of all those zeros. So I just see a very clean 30 over 27 equals 1 plus 0.06 divided by 4, all to the 4t power. Now to get that 4t from an exponent and make it into a coefficient, I'll take logs of both sides. You can take any log you want. Log base 10, log base e, natural log base 15, log base 69. I don't care. I'll take just the natural log. So natural log on the left, I see natural log of 30 over 27. Natural log on the right, I see natural log of 1 plus 0.06 divided by 4 to the 4t. And voila, the whole value of that is that this exponent becomes a coefficient by properties of the log. And so this actually equals 4t times the natural log of 1 plus 0.06 divided by 4. Well, I'm trying to solve for t, but now t is on the ground floor. There's no t's upstairs in the attic. I've got them all down here. In fact, everything else is a number. So I can just solve for t by dividing both sides by this 4 natural log of 1 plus 0.064. And I see that t equals, look how easy this is, it's just this thing, natural log of 30 over 27, all divided by 4 times natural log of 1 plus 0.06 divided by 4. Now that's something we can actually type into a calculator or a computer, and if we do, we'd get 1.769. And that's how many years I have to wait. So I have to wait just under 2 years, right? It looks like around 1 3/4 of a year. So 1 year, 3/4. 1 year, 9 months. I think that's right. 1 year, 9 months, roughly speaking, I have to wait in order for me to be able to buy my car. 1 year and 9 months? How am I going to buy groceries?